Welcome to The Sleepy Physicist. I'm so glad you're joining me tonight. No matter where you are, whether cozy in bed, relaxing on the couch, or just letting your mind wander, this is a peaceful space created for you. Tonight, we'll explore an unusual and surprisingly soothing concept, nothingness. More specifically, what we perceive as nothingness. The stillness of space, the quiet between sounds, and the gaps between atoms. We'll gently drift into the idea of a vacuum and explore why it might be the most beautiful and enigmatic thing in the universe. I've tried my best to make this journey peaceful and sleep-inducing, but there's a small chance it might be too interesting. If your mind stays awake, don't worry. It just means your curiosity is still active, but it will eventually calm down like a wave receding into the sea. The quiet beginning, we start with silence, not just the absence of sound, but a deeper, more profound quiet. Imagine yourself floating in the depths of space, far from any stars, light, or life. There's no wind, no sound, just a vast and endless stillness. This is where our journey begins, not with a bang but with a hush. You might think of space as a vast, empty void separating celestial bodies, a void that holds all the somethings. However, in physics, nothing is never truly empty. It turns out that even a vacuum, the space between everything, is subtly active. The quantum vacuum as a sea. Let's imagine the vacuum as a calm sea. At first glance, it seems completely still, with no waves or movement. But if you sit with it, if you let your mind relax, you'll start to feel a gentle, continuous pulse beneath the surface. Something is moving, not loudly or violently, but constantly. This is the quantum vacuum, and it's not a place, but a subtle presence. In classical physics, a vacuum is just an empty space devoid of matter, air, or dust. Its emptiness defined by what's missing. But quantum physics invites us to look again. When we do, we see that the vacuum isn't truly empty. It trembles, hums, and breathes. The nature of nothingness. This may sound strange. How can nothing do anything? At the quantum level, even empty space is restless, invisible fields, which are the fundamental fabrics of the universe, extend across all of reality and fill every point in space. Even when no particles are present, these fields are still there, trembling faintly. You can think of them like the surface of a lake on a windless night. It looks still, but it's never completely motionless. There's always a subtle shimmer, a vibration so gentle it's barely there. This is 0-point energy, the lowest possible energy a system can have. Even at absolute zero, the coldest temperature possible, the vacuum continues to tremble. Virtual particles. In these tiny, constant trembles, something incredible happens. Pairs of particles appear and disappear. These are called virtual particles. They're not unreal, but they can't be directly seen because they exist for such a short time that they vanish before they can be measured. One moment they're there, the next they're gone, like brief echoes that fade before you can place them. You could think of them as thoughts passing through your mind just before sleep, brief, flickering, not fully formed, but still influencing your experience. The influence of virtual particles. These particles emerge from the vacuum, interact with the world, and then return to nothingness. Yet, their presence matters. Virtual particles affect everything from the forces that bind atoms to the way light behaves near a black hole. Even though they are fleeting, their influence persists. Just as a soft breeze can move a flower's petals, these invisible guests rearrange reality itself. The quantum vacuum isn't empty, it's full of potential, waiting, breathing, and softly shaping existence. It's like a canvas that paints itself before a brush ever touches it, a stage where the play has already begun even before the actors step into the spotlight. A new perspective on emptiness. This new understanding may change how you feel about emptiness. You might begin to wonder, if even emptiness is full of movement and possibility, what else might you be missing? What else might be quietly shaping your world, your thoughts, and your breath without ever demanding attention? It's a comforting thought that even when you feel empty, you're never truly without. Stillness doesn't mean absence, it means depth, and quietness can have its own kind of music. The vacuum around and within you, as you lie there breathing softly, you are already floating in this quantum sea. The vacuum isn't just outside you, it's around you, within you, and between every cell of your body. It connects everything and patiently holds the shape of things before they form. And so, we begin here in the stillness. But stillness is only the first whisper. Beneath it, something even more mysterious stirs. A sea without waves, a field without end. In the next part, we'll dive deeper into the idea of a vacuum and ask again, what is a vacuum really? The slippery idea of nothing. You begin with a simple idea. A vacuum is just an empty space, a place with nothing in it. When you hear the word, you might imagine a sealed jar, a quiet part of space, or a room with all the air removed, perfect emptiness. But this section gently invites you to look closer. In physics, especially the curious world of quantum physics, the concept of nothing becomes wonderfully elusive. What seems empty is actually full, what seems still is quietly alive. Historical perspectives on the void. Let's take a slow step back in time. Before telescopes, equations, or even named atoms, philosophers tried to imagine what it meant for something to be truly gone. They wondered if nature could tolerate a void. Aristotle believed nature abhorred a vacuum, suggesting that wherever there was emptiness, something would rush in to fill it. This idea persisted for centuries, influencing how people viewed the world. They even imagined the heavens were filled with an invisible substance, a mysterious ether, to carry light and the songs of the stars. The rise of modern physics. Over time, science began to unravel this mystery. Air could be removed from a chamber, and pressure could drop, allowing us to study what remained. With greater precision came a closer approximation of nothingness. The vacuum came to mean a space with less matter, fewer particles, and fewer vibrations. Still, the question lingered: is it truly nothing? The constant hum of space now, imagine you're in deep space, far from any planets or stars. It's as empty as we can possibly imagine by human standards. But even there, it's not truly empty. A few lonely atoms, faint light from ancient stars, or occasional cosmic rays might drift through. But even if we could remove all of these, something would still remain. This is where quantum theory begins to unfold. According to quantum field theory, what we call empty space is not truly nothing. It's a fluctuating field, or rather many overlapping fields that span all of reality. These fields are always present, always trembling at some tiny level, even in what we once called a perfect vacuum. The lowest energy state, it's as though the floor beneath reality is made of fabric that is never fully at rest. Even if you remove every object on it, the fabric itself still ripples and quivers. You may be lying still now, but those same invisible fields are passing through you, through your body, and through the quiet room. Even when you feel still, you are floating on something that never stops moving. In this view, a vacuum isn't the absence of stuff, it's the lowest possible energy state of space itself. This subtle hum beneath existence is called zero-point energy, and it's never off. It can't be, because even at the coldest possible temperature, quantum fields still whisper. The Casimir Effect. What's even more curious is that these fluctuations can have real effects. They can shift the energy levels of atoms and create tiny forces, like the Casimir Effect. This is a great example of the vacuum's power. If you place two uncharged, perfectly reflective metal plates incredibly close together, only certain wavelengths of virtual particles can fit between them. Because the space outside the plates has a wider field of virtual particles than the space inside, this imbalance creates pressure that gently pushes the plates together. This force isn't caused by heat or charge, it's the pressure of the vacuum itself. The vacuum is not passive, it actively participates softly and invisibly. Hawking radiation. Virtual particles also play a role around black holes. Stephen Hawking proposed that at the edge of a black hole's event horizon, a pair of virtual particles could appear. One might fall in, while the other escapes. The one that escapes becomes a real particle and energy is lost from the black hole. Over time, this could cause the black hole to evaporate. In this way, the vacuum, through its tiniest ghosts, can even unmake the most massive objects in the universe. The universe is built in blur. There's a comfort in knowing something, in being able to name and measure it. But at the smallest scales of the universe, certainty is a mirage you can almost touch but never quite hold. This isn't a flaw in our perception, it's a quiet law built into the very logic of existence that says some things cannot be pinned down at the same time. This law is called Heisenberg's uncertainty principle. The more precisely you know a particle's position, the less you can know its momentum, and vice versa. It's a built-in blur, not just in what you see, but in what can be. Heisenberg and the restless vacuum. This blur has consequences. In classical physics, a perfect vacuum would be completely still, but quantum physics, with Heisenberg's principle, says otherwise. If a vacuum had exactly zero energy, it would violate the uncertainty principle, because you'd be claiming to know both its exact energy and state. To avoid this, the vacuum must tremble, not loudly, but just enough to remain uncertain. This trembling is the source of zero-point energy, the restless motion that never stops. It's not caused by anything, it's a fundamental requirement of the universe's rules. The soft edges of reality, you can think of it like a violin string stretched across space. Even if you don't pluck it, it vibrates just enough to avoid perfect, impossible stillness. These tiny vibrations are what give the vacuum its depth and potential. They are what allow virtual particles to appear and give rise to forces like the Casimir Effect. Without this built-in uncertainty, the vacuum would be a cold, dead stage. But because of it, the stage hums, and sometimes the curtains part for something to appear. You are part of this uncertainty, and isn't that a little comforting? That the universe doesn't demand perfection and allows for a quiet freedom in every corner. You too are made from this. Your atoms and their electrons hum with zero-point energy. Your thoughts are built from trembling patterns, never fixed, always flowing. You are a brief arrangement of shimmering waves, gently held for a time before the sea calls you,